If you have ever used a compass, then you should know that it always points towards the north direction. But if I ask you a question, how does this compass knows where north direction is? Then you might give the answer that because Earth has magnetic field, this is our Earth and it has its own magnetic field, and geographical north pole is magnetic south pole, and geographical south pole is magnetic north pole. Okay, so when this compass is pointing towards north direction, then it is pointing towards geographical north, but it is attracted towards the magnetic south, because unlike poles always attract each other and like poles always repel each other. But question is, why does Earth produce magnetic field? If we have a current conducting wire, it will have magnetic field. But where is current in Earth? Is there any current in Earth? Well, the answer is yes. In order to understand how current flows inside the Earth, we will have to cut Earth into half and study what's happening inside. So let's do that. We have this cross-section view of Earth. If you cut it into half, we have this crust, then there is mantle, and then we have core. Core itself is divided into two parts, that is inner core and outer core. We are only interested in this part, that is the core part, because the current produced inside the Earth is because of this part. Okay, so this core consists of metals, liquid metals. Okay, especially this outer core consists of liquid metal which is at very high temperature. It is around 5700 Kelvin. Okay, so in this inner part, what happens is, due to very high temperature, metals will gain thermal energy. Electrons, free electrons present in the metal will gain thermal energy, and they will flow in this core. They will move in this core. Okay. Now, since temperature at this inner core is higher compared to the temperature in the outer core. Okay. So, if you have a pan, say if you have a pan and filled with water, if you have a pan filled with water and you boil this water, what will happen? Water molecules present at the bottom will have more thermal energy. That means they will be lighter, they will be less dense. So less dense particles always rise up, right? So they will move up, but the molecules present on the surface have less thermal energy, which will make them heavier, means more dense. So more dense particles always sinks down. So we have this cycle of water going up and down. Okay, so particles which have come from the top will again gain energy and they will again rise up. So there will be a circle of current, and this kind of current is known as convection current. Okay, so same concept can be applied over here. Electrons, free electrons from iron, this inner core is mainly made up of iron, liquid iron, which have a lot of free electrons. So free electrons present over here will have higher thermal energy than the electrons present at the edge, right? So these electrons will be lighter because they will be less dense, so they will rise up, okay, and electrons, cloud of electrons from the edge will sink down, right? So because of which uh, we will have a convection current, okay, and this convection current will flow in each and every part of this core. There will be a pockets of electron flowing here, there will be a pocket of electron flowing here, so there will be a lot of many pockets of electrons uh, flowing, because of which there will be a pockets of convection current in this core. All right, now there is a force called Coriolis force. Because of this Coriolis force, this convection current will move in a circular path. Coriolis force is basically a pseudo force, okay. So it's a different topic altogether. I'll make another video for that, but for now what you need to understand is, because of the Coriolis force, these electrons move in a circular path. So we will have a small amount of current here, and then small pocket of current here, and then small pocket of current here, and then small pocket of current here, and so on and so forth. So we will have many pockets of electrons flowing in circular path, and this circular motion is because of the spin of the earth, because earth moves in around its own axis, because of which these electrons will also move in a circular path, and that is because of the Coriolis force, okay. Now you remember current conducting circular wire has magnetic field, and how you can determine magnetic field of this wire. uh, if say current is flowing in the anti-clockwise direction, then according to the right hand thumb rule, curled finger shows direction of current while thumb shows direction of magnetic field. So magnetic field will be in this direction, okay. So each circular current will have its own magnetic field, okay, and all the magnetic fields will add up to make a larger and stronger magnetic field, okay. So this is the reason why earth has magnetic field.